Welcome everybody. Today we are going to be talking about the product rule, and this is the 2.8 notes. And the product rule is essentially, what do you do when you are asked to find the derivative and you have two functions that are multiplied by each other? And so this is going to be the rule that we'll use, and it's called the product rule. So if f and g are differentiable at x, then so is the product of f and g. And the derivative, so this notation, remember, oops, what do I keep doing? This notation right here means find the derivative. So the derivative of f and g of x is f prime of x times g of x plus f of x times g of x times g prime of x. So notice this is the derivative of my first function, and this is the original second function, and they're going to be multiplied by each other. And then you add the original first function times the derivative of the second function. So we have derivative, original, original, derivative, and we should see like each thing once, right? So we see f prime, f, g, g prime. And so this is just like one of the biggest common misconceptions we're going to make. Like, for example, if you take the derivative of x squared plus 2x, all you have to do is take the derivative of the first piece and the second piece and then add them together. And so that's super easy. But if it was x squared times 2x, the answer is not 2x times 2, right? That is not the derivative. And to kind of prove it to you, so say this is h of x, and then this is h prime of x. So we're saying that this down here cannot be the answer. And the reason that is because if you do x squared times 2x and say first you decide to clean it up a little bit, that would give you 2x cubed. And the derivative of 2x cubed is going to be 6x squared versus this is 4x, right? And so if I simplify this and then take the derivative, I'm getting 6x squared. If I just take the derivative of the two pieces, multiply them together, I'm getting 4x. And so the answers are not the same. And so the big common misconception that I want you to break is that the derivative of two functions multiplied by each other are not the derivative of each piece multiplied by each other. This is not true, okay? So this is not true at all. Do not do that. That's going to be the biggest place you can make a mistake. And so as we handle multiplication in a problem, there are more than one way to do it. So we're going to start by, we'll do the product rule. And so you guys get to make a decision if you want to use a product rule or maybe if you want to like simplify and clean it up. But there are going to be some situations where you absolutely have to use the product rule. There's no way to simplify it. And so if you guys see, we have two functions multiplied by each other here. We have this first function, and then we have this second function right here. And so I'm going to go ahead and name the two function pieces. So I'm going to call the first one f of x, and that's going to be 5x squared minus 2. And then the second piece is going to be g of x. And the product rule says essentially that the derivative of this is going to be the derivative of this times the original of this plus the original of this times the derivative of this, aka it's going to be f prime of x times g of x plus f of x g prime of x. So right here, this notation is like the formal rule, but I don't want you to get like too dependent on this rule. I really want you to just remember it's the derivative of the first times the original second plus the original first times the derivative of the second. I want you to kind of understand the concept of it a little bit behind, because sometimes notation can switch up based on the problem. But again, find the derivative of this. We need to find the derivative of my little pieces. So the derivative of f of x is going to be 10x. And then the derivative of g of x is going to be 8. And then I can just go ahead and kind of like plug it in my equation. And so to find the derivative of this, I'm going to have 10x times 8x plus 3 plus 5x squared minus 2 times 8. And so that right there is the derivative. So this here is h prime of x. Like, you're basically done finding the derivative. You have done that part. From here on out, it's all about simplifying. But this is the derivative. Like, you could be finished here technically, but it is nice to simplify it, especially if you have to plug in a number or you have to like keep using it. It's nice to get it cleaned up. And so I'm going to go ahead and simplify this real quick. I would get 80x squared plus 30x if I multiplied these two. And then here I would get plus 40x squared minus 16, and then I would just combine some like terms, and I would get 120x squared plus 30x minus 16. And so this is method 1 if you're choosing to use the product rule. I'm going to do this kind of over here in the corner, and I hope you guys have some space somewhere, but this would be method 2. So in this case, if you look at the original function, this is just like two binomials multiplying each other. And so you could distribute it out first. You could FOIL it. So that's what I'm going to do here first. So I'm going to do a little bit of this in my head, but 5x squared plus 8x is going to be 40x cubed. 5x squared plus 3 is going to be 15x squared. Negative 2 times 8x is negative 16x. Minus 6. Again, simplify this. Oh, wait, I can't simplify that. It's simplified. Okay, and then you just would take the derivative of this. So the derivative of this is going to be 120x squared plus 30x minus 16. And so it is the same thing. And so that is a way that you can check your answer. And in this case, you might actually find this one easier than using the product rule. So essentially, like the reason we could use this is we got rid of the product by multiplying. And so then this is just a bunch of addition and subtraction, and so you can find the derivative. But you need to know the product rule because there's going to be situations where you could not use an alternative method. You would have to use the product rule. And we'll look at more examples of that in a second. Okay, here's our example 2 problem. This example, again, if you look at it real quick, there are two ways that you could solve this. You could use the product rule, or you could go ahead and multiply and get rid of the product, and so then you wouldn't have to use the product rule. And so we're going to do both. We're going to start off by using the product rule. So I'm going to call this first function, the one that I just highlighted, I'm going to call that f of x. And so that's negative 4x cubed. And then I'm going to call the second one g of x. And to remind you, the product rule says the derivative of the first function times the original second plus the first function times the second function, the derivative of the second. And so that means I need to know the derivative of the first function, which would be negative 12x squared. So I'm just taking the derivative of this. These two go together. And then the derivative of g of x is 2x. So eventually what I'm doing over here at the side, you're not going to need to do that. You're going to be able to do this in your head. But now I'm just going to plug things in. So this is going to be negative 12x squared times g of x, which is x squared, plus f of x, which is negative 4x cubed, times the derivative of g, which is 2x. And so at this point, I actually have found the derivative. Like, this is the answer. Now I'm just going to simplify my answer so that it's easier to use if I need to use my derivative for something specifically, or if I need to plug something in. So this will be negative 12x to the 4th power minus 8x to the 4th power, and that's going to give us negative 20x to the 4th power. And so that is the derivative of h of x. So that did take a lot of work. If I show you method 2 over here, I think it's personally a lot quicker. But again, we're going over this because you need the product rule sometimes. Like, there's some functions where you absolutely do need it, or it would just be easier to use. And so what I'm doing here first is it's still saying h of x because I'm still working with the original function. I'm just cleaning this up a little bit, so it's negative 4x to the 5th power now. And so now that I've multiplied, my product is gone, and so I don't need to use the product rule anymore. And now I can take the derivative, and I get negative 20x to the 4th power, which is what I got over here. So I basically just checked my work. And so if you ever want to, you could do both methods to make sure your answer is correct. Okay. We're going to do another example here. We're still just going to use the product rule. I'm not going to do both methods. But again, this is a problem where I probably would I would choose not to use the product rule, but we're just trying to practice the product rule. And so that's why we're going to use it. So I'm going to highlight my two separate functions. Notice that this is called f of x, the whole function is called f of x. So I'm going to call my pieces different things this time so that I don't have a double f of x. So I'm going to call the first function g of x, and then that'll be 25x. I'll call the second one h of x, so this will be 8x squared plus 4x minus 3. So those are my two pieces that are multiplying. So then I'm going to define my product rule by the derivative of the first function, which in this case is g, times the original second, which is h of x, plus the original first function times the derivative of the second, just like that. And so that is still the product rule. I'm just using different notation. So the derivative of g of x is 25. The derivative of h of x is 2x plus 4. And now I will just plug in to my product rule. So this will be 25 times x squared plus 4x minus 3 plus 25x times 2x plus 4. And here, at this step right here, I am done. I have found the derivative. As soon as you write f prime of x, you have found the derivative. But now I will just simplify. So this will be 25x squared plus 100x minus 75 plus 50x squared plus 100x. And now I will combine some like terms. So these guys go together. I'll get 75x squared. These go together and I'll get plus 200x minus 75 will be my final answer. So that's my answer. Okay, we're going to go into some problems where you actually cannot do it without using the product rule. So for example, sine of x and x to the negative 2 power, there's no way to like simplify that where you could get rid of the product. There's no way to like combine sine x and x to the negative 2 power anywhere. So I'm going to use my product rule. You guys are welcome to try this on your own. I'm going to call the first function f of x. And then I'm going to call my second function h of x because g of x is like the name of the entire function, so I don't want to get anything confused. So then f prime of x is cosine of x, right? I always forget the derivative of sine. I always forget which ones are negative and which ones are positive. So let me confirm this real quick. Okay, yeah, sine of x is cosine of x, but cosine of x is negative sine. And then the derivative of h prime of x is going to be negative 2x to the negative 3 power. So now I'm just going to plug in, and I'm not going to write it out this time because I want you guys to get used to not, but it's the derivative of the first function, so that is going to be cosine of x, times the original second function, which is h to the negative 2 power, plus the original first function, which is sine of x, and then the second one, which is negative 2x to the negative 3 power. Because I started this problem with negative exponents, when I simplify it, I'm just going to leave the negative exponents because that's how it was given to me. The only thing I'm going to do to simplify is I'm going to bring the minus 2x out in front. So I'm going to have minus 2x. Or I'm just going to bring the minus, yeah, I guess I'll just bring them both out in front. It's the same thing, but I just like when the coefficient leads. So that's the answer for this one. I'm going to keep moving. Okay. Now this one is different because it wants to actually find the derivative at a point here. And so I'm going to like take the derivative completely and then I'll plug in 1 at the end. I feel like that's easier for me a lot of the time. So f of x is going to equal e to the x power. I'm going to call the other function the natural log of x. I'm calling it h this time because g was used to name the entire function. The derivative of f of x is e to the x power, and then the derivative of h of x is 1 over x. And so that means that g prime of x is e to the x power times the original second, which is the natural log of x, plus the original first f function, which is e to the x, times the derivative of the second function. And then I'm not going to clean it up because I'm just going to go ahead and plug in 1. So I have e to the 1 power times the natural log of 1 plus e to the 1 power times 1 over 1. And so to simplify that up, it's pretty easy. The natural log of 1 equals 0. And so this would be like e times 0 plus e times 1. And so the answer to this is just going to be e. And you can write e to the 1 power if you want to, but it's the same thing as e. And that, remember, e is not a variable, e is the number. It's like something equivalent to something close to 2. So that's what you would do if you're finding the derivative at a point. You would find the derivative function, and then you would go ahead and plug in 1 after that. So this one says find the equation of the tangent line at x equals 1. And so for this one, I'm going to do the derivative. Well, so it's the same function as last time. So we figured out in the last function that g to the x equals, well, we actually really did all of this work in the last problem. So because we're trying to find the tangent line at x equals 1. So remember, when you find the tangent line, you do y minus y1 equals m times x minus x1. And the m is the slope of the tangent line, aka the derivative. So this is the derivative. And then the x1 is just a point on the line on the original function. So this is a point on x. It's just like a point on g of x. And so is this one. So I already found the derivative at 1 from the last problem. So I already know in the last problem that e is the derivative. So because this is the same function, right? So we just did that. We figured that out there. And then we want to find the equation of the tangent line at 1. So that means it's going to be x minus 1. So all I have to figure out is the y1 point. And if you think about your function, right, anywhere you would draw a tangent line, the original function and your tangent line share that point. And so if I want to find out what y1 is, I just have to plug it into the original function. So I'll just do it over here, g of x, well, I'll just plug g of 1 in, e to the 1 power out over the natural log of 1. And this is going to equal 0 because the natural log of 1 is 0. So this will be y minus 0 equals e times x minus 1, which you could just say y equals e times x minus 1. So that is the slope of the tangent. Last couple of problems, we're almost done. So these next two problems are just going to be the product rule with tables. I feel like these are really helpful because it really helps us like recognize the notation of the product rule. And so this one says let h of x be defined as h of x equals g of x times h of x. And then it says find h prime of 2. And so I noticed that this is a product here, right? So this is a product. And so that means I have to use the product rule. And so this is going to be h prime of x equals g prime of x times h of x plus g of x times h prime of x based on what it told me. And then I'm trying to find it at -2. So all of these x's, I'll just go through and plug in -2. And then I just use my table to find all these other values. So it says g prime of -2 is 3, h of -2 is -1, g of -2 is 2, h prime of -2 is 4, -3 plus 8 equals 5. And so that's your answer. I went through that like very quickly, but you can feel free to pause and try to look over what I just did. And then we'll move on to the next one. Okay, last problem, and then we'll be done. Same idea. It's trying to find the derivative of a product. And so based on the way that they wrote this, that means the derivative is going to be f prime of x times h of x plus f of x times h prime of x. And then we want to do this at -1. So -1, -1, like that. And then f of -1 is 1. H of -1 is -4, f of -1 is -3, h prime of -1 is 3. This would be -4 minus 9, and that equals -13. And that is it. Thank you for watching.